Let's go through LeetCode 799 Champion Tower. For this question, it let us to simulate the here there is a champion tower, and let's simulate it. We pour the champion from the top, and there is a quarry row in the quarry glass. So it says that if we have a poured number of champion, and then we pour from the top, and it asks at the index query row and the query class what kind of how much the champion is in the class. The top row, the top class, it has index 0, 0. So let's look at the example. If we have one class of champion and we query row 1 in the class 1, or say column 1, right? Row 1, column 1. Then that is this one. If it is one class, we just fill this out. So this is 0, right? And if we have two class of champion, then this is filled out. So there are we fill another class of champion. It will link to this, right? So for the actual class of champion, it was split in 2, right? So we ask at this position how much champion it is. It is 0.5. And let's look at simulate again, right? For the third one, where it will fill this out. And the fourth one, because this the first row, second row, they are filled out. So there are more leaking out. And so for this one, there are 21 cup. This one, there are 21, right? And then split here, this is 1/4. This is 1/4. And this is 1/4. This is 1/4. So this will be 1, also 0.5, right? And the same thing about the fifth, right? Fifth, this will be half, but this will be 4, right? And the sixth, this will be 3/4, and then here there will be 1/8, 1/8 to go down to the next layer. So what we're thinking about is that for the actual champion, if we can set the index, for example, this is for row 0, column 0. So we can find for this kind of the champion in this kind of class, it will link into 1, 0, 1, 1, right? So for any champion which is in row I and column J, if there are actual champion, if it is filled out and there are actual, it will link into the class I plus 1 and J, and I plus 1, J plus 1, right? So I link into these two. So we just simulate the process. What we do is that we put at the beginning, put all the ones in the first top glass, right? So we have trying to see this is filled out or not. If it's filled out, then we'll have actual equals pool, right? Actually, we'll say this number. We can use a 2-dimensional array, which is query row, for example, multiple by query class, right? And at the beginning, this is what we call this array of tower 0, 0, right? It is port, right? So we'll say if this port is greater than 1, right? Then we just have actual to be -1, right? And it was split by 2, right? And to the next layer. So we just simulate the process. Let's begin to write code for this, right? So we know for every query, we are going to return, for example, this tower query row, right? Query row and query class, right? So at least for this array, we should have this +1 and this +1 row and a column, right? But also because for our column j, we are going to leak into j and j+1, right? So we need at least this to be +2, right? So let's begin to write code for this. And we'll have a double tower equals new double query row +1 query +2, right? Of course, you can also use this kind of number to be the column, right? To calculate everything. But actually, because we are just query to this class, right? So it may be in the middle. And we know every j, it is only coming from I minus 1, j minus 1, and I minus 1 j, right? So we just need to have a so we'll see. We for this kind of query, we just need to have the query class to +1, this kind of calling. And when we calculated this, right, we should add 1 2, right? Because for the last one, it will maybe class +1 class query class and class +1, right? So we don't need to calculate every classes in each row. And at the beginning, we'll say that tower 0, 0 is we put everything into the top one. So what we do is for int I equals 0, right? I smaller than query underscore row. We just need to we are calculating from the row row I to row I +1, right? So we iterate to smaller than query row should be enough. And I will say for int j equals 0, j is smaller than query class +1, right? Because here we need +1 because always say equal, smaller equal to query dot class because we need to iterate to this one. Every for this index, we should always at least to this index, right? G plus plus. So let's say So we'll say, if power I j greater than 1.0, right? So that means there are actual. So we'll say, tower I plus 1 j should plus equal to. So what is the actual, right? So double actual equals this one, minus 1 should divide by actual divided by 2.0, right? And tower I plus 1 j plus 1 should plus equal to divided by 2.0, right? And in the end, we just return the, the same thing that if we have actual greater than 1, then means this is 4. Otherwise, we just return tower query row and that query class. Right, so we'll say max.min 1.0 tower query row query class. Okay, so actually for this question, when we look at that every row, when we calculate to only there are only 2 rows being involved, right? So the row I will calculate to row I plus 1. So we can also get this one to be we can also optimize its space complexity by only use 2 rows. So the thing is that for each iteration, right, we need to initial the next row arrays field tower. Let's do this I plus 1 to be 0.0, right? And for every I, we just multiply by 2 here. In the end, the return is multiplied by 2. So in this case, the time complexity will be query row multiplied by query class. The space complexity will be 2 multiplied by query class. Let's change this one to be Python code. So we need a double 2-dimensional array, right? Tower equals. So in Python, we define 2-dimensional array as this, right? 0.04 in range. So we know for the column, we need to have query class plus 2, right? And for this, for every, this is 2 row, right? So we need this one for in range 2. So we write this, and initially we set tower 0 equals 1.0 multiplied by port. And then we do similar things for I in range query row, right? We just need to iterate to query row -1, right? And we need to initialize the next row, tower I +1 mod 2 equals and multiply query first. Then we'll say for J in range, query class +1, right? So we'll say if power I mod 2 J greater than 1.0, then we'll add the actual one, right? Power I +1 mod 2 J. Let's set the actual, actual equals power I mod 2 J -1.0. So class equal to actual divided by 2.0. And also for the J +1, we also need to add this actual ones. And in the end, we need to return minimum 1.0 power query row mod by 2, right? Mod by 2, and the query class. This should be princess. J is auto index. J is auto index. So yeah, let's put this one into +2, right? As we mentioned. So J is yeah, J this range should be +2. And we should have this one +1, right? Machine power J +1 in And this is plus 2 should be, oh yeah, this is plus 2. And j plus 1. Actually, this should be plus 1, right? Index should be smaller or equal to which one? Tower. So I plus 1 multiplied by 2, j plus 1, j plus 1 equals what's the power now? J range. It's okay now. Okay, so this time complexity is Corey glass multiplied by 2, right? The space time complexity is Corey glass multiplied by Corey row. Space complexity is Corey glass multiplied by 2.